Solving inequalities using multiplication or division. Objective: to use multiplication or division to solve inequalities. Okay, multiplication property of inequalities. Now, this is a fancy diagram to say if you multiply both sides by a number, as long as that number is positive, the inequality symbol stays the same. But if you multiply by a negative number, then you have to flip the inequality. Okay, it says what are the solutions of c over 8 is greater than 1/4? So I'm going to rewrite this. C over 8 is greater than 1/4. So I'm going to multiply both sides by 8 to get c all by itself. 8 cancels out on this side, so now I have c is greater than 1/4 times 8 is 2. Notice I didn't flip the inequality because I multiplied by a positive number. And you can check to make sure that this is true. Let's pick a number that's greater than 2. Let's say 16. And the reason I chose 16 is because it's going to make this a Captain Obvious moment. Okay, so I'm going to choose c equals 16 because 16 is obviously greater than 2. And so I'm going to say 16 over 8, is that greater than 1/4? Well, 16 divided by 8 is 2, and 2 is greater than 1/4. So I know that I was right, that I didn't need to flip the signs. Example 2, it says, what are the solutions of negative n over 3 is less than negative 1? Okay, so I'm going to start off, I'm going to rewrite this again. I'm going to say n over negative 3 because I want to put the negative with either the numerator or the denominator when I'm trying to solve like this. And it's easier because I want to put it with the number as opposed with my variable to reduce the number of steps that I have to do. So now because I'm dividing, I'm going to multiply both sides by negative 3. These guys cancel out and I have n. Now because I'm multiplying by a negative 3, I need to flip the sign. So I have n is greater than, let's see, a negative times a negative is a positive. 1 times 3 is 3. Let's check to make sure that we're right. Okay, so I need a number that's greater than 3. I'm going to choose n as 9. So let's see, I'm going to say 9 divided by negative 3 is less than negative 1. 9 divided by negative 3 is negative 3. Is negative 3 less than negative 1? Yes, because I would rather owe someone $1 than owe someone $3. So it is eating the larger number. So I know that I'm right. And now when I go to graph this, let's see, 0, 3, 5, 6, whatever makes you happy. And I have an open circle at 3, and it says n is greater than that, so I'm shading towards a 5. Okay, same thing with division. If you need to divide, if you're dividing by a positive number, the sign stays the same. If you're dividing by a negative number, you have to flip the sign. I shouldn't say sign, the inequality. Okay, it says a student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. The club can spend at most $50 for this project. What are the possible numbers of cases the club can buy? Okay. On this one, we're spending $10.68 per case. So we're going to say 10.68 times the case, or the number of cases, and it says it spends at most $50. So I have 50 over here, and I have to decide which inequality goes there. Can I spend more than $50? No, because it's kind of indicating that they only have $50. So that means that right here is we're starting off with money spent and $50. Well, I don't have more than $50 to spend, so that means what I spend has to be less than 50, but it could also be equal to 50. So I'm going to make sure I put my inequality over here. Okay, now, to solve for the number of cases I can actually buy, since I'm multiplying $10.68 times the number of cases, I'm going to divide both sides by 10.68. And so I get C has to be less than or equal to, and when you graph or solve this one, you're going to get a number of 4.68165. Now we can't buy part of a case, so that means when it says what are the possible number of cases the club can buy, well, they can choose to buy no cases in case they have their $50. 1, 2, 3, or 4, because all of those are in their price range. Example 4 says, what are the solutions of negative 5x is greater than negative 10? Okay, so I'm going to rewrite this. Negative 5x is greater than negative 10. I want to solve for x, so to solve for x, I'm going to divide both sides by negative 5. Now notice I'm dividing by a negative number, so that means I'm going to have x. I'm going to flip my inequality. X is less than, a negative divided by negative is a positive, so I get 2. Now, I want to check and make sure that's right, so I'm going to choose a number that's less than 2. Anytime I can choose 0, it's easy math. So I'm going to come over to the side and say, okay, 5 times 0, is that greater than negative 10? Well, anything times 0 is 0, so I have 0 is greater than negative 10. Life is good. Okay, so now I need to graph this. Let's see. I'm going to have my 0, 2, and I could say 4. Notice it's not equal to 2, so I'm going to have an open circle at 2. And it says it's less than that. We already tried 0 and it worked, so I'm going to shade towards the 0. Okay, lesson check. I do want to point out something real quick. If I had had a number like 5x is less than negative 10, if I divide both sides by 5, do I flip the sign? No, because I'm dividing by a positive 5, and so I would have x is less than negative 2. It doesn't matter what this number is. It matters what you're dividing by or multiplying by. As long as it's positive, you do not change the signs. Okay, on the lesson check, make sure you've tried all 6 problems before you come to class.